And our next talk is dedicated to BE-terna, one of this year's bronze partners whose significant contributions have helped bring our vision to life. This marks another milestone in our long-standing partnership, and we look forward to many more to come. Nino Pozar, product owner and data scientist at BE-terna, will be presenting Alisa AI, future-proofing your business with demand forecasting. In this session, Nino will demonstrate how BE-terna's Alisa AI solution uses advanced algorithms to predict future demand, optimize inventory, and improve profitability. Through a real-world case study, he will share practical strategies for applying demand forecasting to enhance business decision-making. Please welcome Nino Pozar to the stage.
I'll wait still a little bit. Okay, I'll start because I still need to, in the beginning, tell a little bit about myself and about the company. Okay, I'm already introduced like Nino Pozar, but just a little bit to say about BE-terna. BE-terna is a company we usually say that we develop business solutions for our customers, so part of it is also AI. So we have AI team within BE-terna, and the main thing we do is this product, Alisa AI. So to start, what actually Alisa means, these days everyone names their product some way, Siri, Alexa, and so on. So we also decided to go with that direction. So it's an acronym that stands for Automated Logistics and Intelligent Supply Chain Assistant. Obviously, from the name, you can kind of figure out that we implement AI in the domain of supply chain and logistics. So how we envision the product to be AI-powered intelligent assistant to automate, simplify, personalize, and optimize those complex supply chain processes. And our focus is on retailers, wholesalers, and manufacturing companies. But we'll go deep into that more afterwards. So how I envision this presentation is to first actually introduction in supply chain. I don't know how much any of you are experienced in the field of supply chain. So to see what problems are our clients actually dealing with. Then focus a bit on demand forecasting, because actually everything depends on demand forecasting. Then to see how we came up with our solution for demand forecasting, and in the end to see what are the benefits that Alisa actually brings to our clients. So that's basically what we're going through in this presentation. So the challenges in supply chain, to see them somehow from the perspective of one supply chain company does, for this example, everything. So like our perfect client that fits wholesale, manufacturing, retail, and so on. So this company in the beginning, because it's producing something, is also a manufacturing company, needs to have something to work with to produce stuff. So the first thing that happens, they have to make a purchase orders to their own suppliers and get some raw materials on stock. And then you have those raw materials, raw goods, and you do something on your lines, on your machine, so you schedule work orders, and you're starting to produce your final product. So you have to schedule stuff when something is going to be produced, on which line, how many people you have, so you're optimizing this process. And you end up with your final goods, final products you're selling to the end consumer. Then comes the next part, because this is a perfect line that we want. It also has your own retail stores, so you have to send the right amount of items into each store where the item is actually going to be sold. And you always have the wholesale part that you also have to account for in the beginning, that will be sold via wholesale. And then what also happens is that in retail business, different stores still have different sales dynamics, and you still have something like transfers between stores, because different sales dynamics mean that you're missing a store, missing a quantity of items, some have surplus of an item, and you're doing store transfers. So this would be like overall supply chain company. So to repeat once more, you're ordering from suppliers raw materials, you're using raw materials to produce final goods, you're sending final goods to your retail stores, and in the end, you're making transfers between stores to actually sell everything as soon as possible, have happy customers, and generate the most profit you can. So what are the points where Alisa actually comes in? Number one is demand forecasting, to actually know your demand, how much are you going to sell in the end. Second part is that you want to automate the ordering procedure. Third part is that you also want to optimize and automate scheduling of purchase orders. Third point is then store transfers. And the heart of everything is demand forecasting, because all of this depends on demand forecasting. If you have good demand forecasting, you can automate purchases, you can do good store transfers, you can automate and optimize your manufacturing. But the truth is, forecasting is hard. I had one colleague, actually, professor, which works highly in supply chain, that told me that if you do good forecasting, you can do everything well in supply chain. But the truth is, it is hard. It's hard to estimate the right demand. So what are actual consequences of bad forecasting? I wanted to show this from example from a person, from an end user. And this end user is Bob, who is a planner and purchaser at one company. So what are consequences if he doesn't do good forecasting? Number one thing is that he's ordering too much, so his stock levels, his levels of materials, of final products are too high, or he's missing items and he doesn't have enough to produce. The other thing is that he's spending a lot of time making purchase orders to his own suppliers. Then comes the second point, where he's using money for dead stock, something he's not even selling or using. And on the other hand, he's losing money because he doesn't have enough to sell some stuff, because he didn't order too much, because he didn't do good forecasting. Then comes the third point, that you don't have enough materials to produce something, and your production orders are late, because still, you could do better, Bob. Then comes point 4, which means that in warehouse, you have no control of what's going on. So if you have a good solution, you know what's coming in, and you kind of don't have any jams in your warehouse. And the final point is that even though Bob does all of this by himself, spends so much time doing it, the truth is that he also has a new colleagues. You know, we all change companies, so somebody new will come and he has to teach the new person all he knows. And not just that, let's just forget what happens if Bob goes sick and he leaves for a couple of weeks, then the hell breaks loose in a company. So why forecasting? Why focus on that, and why actually use machine learning for forecasting? And I'm trying to put this from an example, how it works. So imagine you have a time series like this. I'm going to put some example, like dummy example, how it looks like. And you want to forecast this true value. So what our clients, before they implement our solution, usually do? They do something like this and say, let's average the sales in history, and say this is going to be the value that's going to be sold in the next period. And you can see it's kind of off, and truth be told, this is really seasonal sales. You know, there are sales some up and you have a little down, up and down, so you are wrong, and you're going to miss this item. Some clients get more tricky, and they say, you know, yeah, okay, the item is seasonal, I will just look at the sales from last year. But what if I told you that these sales from last year are not really that representative? Because I will tell you that there were promotions last year in this period. This year there is no promotion, that's why sales were this high, and they still would estimate totally wrong value. They can get even more tricky, and they can say just last period. Just look at the last value and just forecast the same thing next time. But this is a seasonal item. The seasonality is definitely not affected by this forecast. Some get even more smart, and they use some statistical methods. You know, ARIMA, like autoregressive, and you model the trend, you model the seasonality, and so on. But still, you're missing the context of promotion. And I will tell you also a secret. You know, sales are 0 in these periods down here. Those were actually you couldn't sell. There was a context why there was a 0. So here where machine learning comes, and why do we even use machine learning for situations like this? Because you can model stuff, you can build features out of it. So you can build features out of sales, You can build features out of promotion, you have specialized feature, and you extract features out of promotional periods that were this period. You extract features that were inability to sell, some events happened or something, some calendar. You get more features, you get competition data, you get outside effect, external features, weather features, economical features, and so on, so on, and so forth. And it depends on what fits the model the best. And out of that, you can definitely forecast better using machine learning. So, how does it work? You know, you have now machine learning, you kind of know intuition how it does it work. And why does it work for us? You know, the first thing comes in is that we connect to different data sources. We connect to ERPs, you connect to the databases, the external data. But the most important thing is, you know, previous presentation said the garbage in, garbage out. After all, if you put completely different data in, then it's not representative, you get bad forecast. Then you clean the data, you extract features, prepare your feature vectors, and so on. So this means finding outliers, detecting stockouts, price promotions, and so on and so forth, substitute data and so forth. Then you're building features out of it, features that can be date sales features, contextual features, external features, and you're building different machine learning models. What we do, we always focus on an end item, and we use different algorithms for machine learning, different granularity, whether it's a daily forecast, weekly forecast, monthly forecast, and we are forecasting per each location, and we're also using more information about, not just about the same item, but also on the context of the whole, let's say, store, brand, or whatever it is. And when you combine all of that all together, you get your forecast. But this is an easy one. This is an easy one. You see what you see here are historical sales on the left, the gray ones, and the blue ones, the forecast. But constant item, you can even with the average do a good job with forecasting this. But when the complex things come, for example, you can have sparse sales, where sales really happen on sparse times. And here the problem actually is not even a regression problem, it's a combination of classification and regression. The question is when then the sales were happening and how much, if they happen. So this kind of example. You can have even more complex examples, you know, seasonal sales that you definitely catch with machine learning models. Even other examples, outliers in data. We detect outliers here, and we are definitely not forecasting according to the outliers that happen in history. More example, this is a really, really interesting example because you can see that forecast is actually pretty good, but if you see training data, you wouldn't forecast this from the training data. But what if I give you context that in these periods where the sales are pretty low, there was a substitute item. So there was a replacement item that was sold instead of this item because this item didn't have an ability to sell. So you combine the data, you enrich your data, and you build a better forecast. Then another example, I said promotional periods. Definitely, promotional periods definitely affect the sales. The lower the price, promotion, and also just promoting the item affects the sales. If there was a historical promotion, and you're already planning promotion on an item, definitely it will affect sales. Also, an interesting thing is new items. We worked on a project with this in fashion industry, where the sales, you know, they are really seasonal things. When you talk about fashion, we're talking about shoes here. Every year there's a new item, so you don't have history to forecast from. So what we do, we look for the similar items in history, whether it's from photos, whether it's from attributes, and when you find similar items, you can see here examples. So you can look at these heels, and you find similar heels in history. You can find this shoe, similar items in history. Another shoe, similar items in history, even from the photos taken by hand. And what you do, you use the data from similar items to get the forecast for your new item. So that's about demand forecasting, what Alisa does. But what is everything about Alisa? So it's not just demand forecasting, even though it's the main thing, as I said. We use all the information about forecasting, and that's the heart of it. That's where everything starts. But forecasting allows you to do order recommendations, so automate your ordering, how much you're going to order from the customer to all constraints, packaging, safety stocks, dynamical calculation of safety stock, and so on. Then is manufacturing planning, what Alisa also does, which means that you're scheduling your work orders according to many constraints. So when something is going to be produced, according to shifts, according to people you have available, according to materials you have available, lines you have available, broken machines, and so on and so forth, constraints as much as you can, genetic algorithms, evolutionary algorithms like that. Then replenishment of stores, specialized for retail, especially where you have assortments and you have to force items in different stores, how much is surplus in a store, how much is short in the store, that also Alisa does. Then alerting, because it's not just, it's an assistant that alerts you that in the morning you know that today you have issue with some work orders, that you have not enough materials to produce, that you have to think about replacements and so on. So it really alerts you on the problems you might have. Then APIs, because all of this is like a black box to end customer. It means that it connects to your data source, ERP system mostly, and directly returns the data to ERP system. So it's completely not another system to maintain, so to say. So connects to existing data and just returns the results overnight to ERP back. KPIs and reporting, I want to actually really stop on this part because I worked a lot with clients over the years. And one thing that I really stood up to me is that, you know, people still don't believe in, maybe now a bit more when you told them about AI and so on because of ChatGPT, but when you do forecasting, our clients usually say, it cannot do that. You know, then they actually see the results, they can kind of trust the system. That's why we usually do some BI applications that actually show the results and why the results are as they are. To build that trust between the system, Alisa, and on the other side, the end user, not just the client, but that end user, that Bob, who actually has to make a purchase order every day. And in the end, we also build assistant in our BI tools, which allows our clients, our end users to actually communicate also with the system to explain results, go through documentation, why something means something, what is this field meaning. Also, it allows you to scrape some data online and get statuses of items. And I want to see now, I kind of try to give introduction what supply chain is, what are the issues of one end user, one of our users like Bob, what Alisa does, and now let's see how it helps Bob, but actually helps in his business, nothing else. What it means that, you know, as I said, it connects directly to your data source. If it connects directly to your data source, it also returns results overnight directly to the data source. So, truth be told, it can be a system that you don't have to do anything with. But, as I said, building the trust between user and the system means that you show the results to the end user. So Bob, every day, gets the prepared results in the morning. He wakes up, maybe works remotely, maybe goes to job. When he opens his laptop, he gets the results already prepared. The main thing in this app that he sees is this table. This table, which is the table of all the items that he has, and in the end field, the ordered quantity, so completely automated. The forecasting was done, ordering was prepared, safety stocks calculated, and he knows how much he has to order today for this item. And in the middle are some KPIs, you know, forecast, previous sales, so he kind of knows why the results are as they are. He can review a single item, so he can select a single item. On the right side, he can see the, maybe I'll copy it. He can see the historical stock levels, the future stock levels, historical sales, and future sales. Actually, I enlarged it. So historical stocks and future stocks, how it would look like according to forecast. So why it's ordering as much as it's ordering. And then you see the forecast that it did. And he can, you know, even change values directly in BI tools. I know how many of you worked in BI, Power BI, Tableau, Click, or whatever. Usually they are just reporting tools, so we even allow changing the value. So he can review the item, he can directly change, you know, 132, he doesn't agree with 132, just changes the value, clicks yes, and again, directly sent to ERP that the order was changed. Because, you know, he knows his thing. Something came up today in the morning that the system didn't even know about, so he wants to change the value. And all he has to do then, click confirm, send everything to ERP, and purchase order is created, requisition order is created, directly sent to his own supplier. His job here is done. You know, just an example of this, we had a client, they worked for 2 days. They were making transfers between stores. And for 2 days, a guy was literally from 8 until 4, you know, looking at every item, making hand transfers from to where something's going to be moved. Today, he gets results Monday morning, and if he wants, it's 10 seconds time to actually do everything, and the results are even better than they were before the system. And as I said, just a click of a button, everything created in ERP. It doesn't even have to be click on a button. It can be directly integrated overnight. And to end the story a bit, to see the benefits. If you remember the issues I spoke in the beginning, most of it was either that Bob is ordering too much of items, either is ordering not enough, or is just spending so much time on it. So everything depends if you automate the stuff and you're doing a good job forecasting. So the benefits that come out of this is that everything, most of the job Bob does is transferred to algorithms of Alisa, whether it's machine learning algorithms for forecasting, or it's like rule-based algorithms for ordering, then evolutionary algorithms for manufacturing, scheduling, and so on, but mostly built-in algorithms. And if you use any algorithms, you're automating your process and you're using much less time on your job. The next benefit, as I said, when you're not forecasting well, you're either overstocking or understocking. This means that if you are better at forecasting, you're decreasing stock levels, you have more cash because you're spending less cash on items that you're going to stay in there and do nothing. And with that, basically with that extra cash, you can spend it on other stuff in the company. And increased profit comes from less lost sales, less out of stocks. If you come to the store and there is no item to buy, you don't buy it, you go to your competition. But if there is item to buy, then you're going to buy it and you're going to earn some money on it. So this means that transfers or the forecast are in location where there is higher probability of sale. Then increased service level, I didn't talk much about it. That's mostly related to manufacturing because you're reducing production times. It's not just scheduling work orders, it's scheduling it to mostly utilize your machinery as much as possible. If your machinery is utilized as much as it can be, then you're using less time on it. When we developed this part of the solution for the first time, it was for one company, and they were actually in a point where they were thinking about buying a new machine because they were, number one, working weekends, number two, working third shifts. And by just optimizing the schedule, finding the better schedule, they didn't have to do it. They didn't have to buy the new machine that's why, I don't know, really expensive machine, just say it. And of course, in the end, you have less delays in deliveries because you have item available. There are more benefits to it, so extra time, because Bob is definitely saving time on it. He can maybe focus on some more complex things. There are always complex things. There are always things that you cannot do good forecast on. Rollout is easy because you're just transferring everything to algorithms, new store, new country, new item, everything for rollout is easy. I was talking about this a lot, about verification orders through dashboard, how much this user interface, direct interaction with the user means. Then the whole control, because you know what's coming, because actually you have everything digitalized, so to say, from the beginning. You're not doing anything manual, don't have thousands of Excels, so you have much better control over what's happening, when something is coming, what is coming, when it's going to be sold, likely be sold, and what is going inside your company. And in the end, you remember what it was her name, Eva? She is the new employee, and as I said, if you have something that can be done in 5 seconds every Monday, then even Eva can do it from the first work day. And imagine this guy that his job we automated, so to say, he has like 20 years of experience. And I would honestly say that nobody can take over his job, because just working with him as a client, this guy knows so much about his internal company, how he does his stuff, and just to see how everything was translated into algorithms is just amazing. I remember the first meeting with him, he literally said, "This cannot be done. I don't trust you that you can do this ever." And no, and like 2 years later, I think he changed his mind now, and it's much easier for him to work. I mean, when he actually has time for his private life after job. So I wanted to conclude with this, that Alisa, the product I presented today, allows us the ability to automate stuff, so automation of ordering, automation of planning. It allows us to have controlled stock, increase profit and cash flow because you're doing less overstocks, you less out of stocks, increase service level because you have the item available to be sold to the customer. And truth be told, one thing, if you're a retailer and you know when you're every time going to a single shop and you have nothing, the thing you really want never to be buy, you kind of always go to your competition. And in the end, it's just the control of the movement in the warehouse, to have the right product, at the right place, at the right time, across many industries. So really, we work with diverse industries. We're not even specialized in industry, whether it's a fashion industry, machinery industry, food industry, hospitality, regular retailers, I don't even know how they call it, like pet food retailers, like really a lot of industry over the years. And I want to conclude with this. You know, I put a little photo of like a lot of pictures of our team. So if somebody wants to join and be next year here instead of me presenting this new solution that we do, feel free to contact us. And that's it from me.
Thank you very much for joining us. This is for you. Our coffee break has started, but we have time if anyone wants to ask a question. Yes? Well, 1, 2, 3 questions we have. Let's start. Ladies first.
What is the smallest level of granularity, if you can share that with us, that you use for demand forecasting? That's the first question. And the second question is, what are the most common limitations of your solution?
What was the first question? What are? I usually don't hear well. Really, honestly, I don't hear well. I'm honest with everyone
No
here.
problem.
I don't hear well. So if I ask 20 times, I will ask 20 times because I don't hear. You talk well.
No problem. But the first question was, what is the smallest level of data granularity that you use for demand
Okay,
forecast?
I will first answer the first question. For now, we use like forecasting part. We use daily, weekly, monthly, and the algorithm learns itself how to use it. What's the best thing for an item actually? When I'm saying daily, monthly, weekly, you can always aggregate stuff. This is what fits most of our clients the best. But sometimes clients want to use this for financial planning because that also can be applied, and they just group it by year and they have a yearly plan.
And regarding portfolio?
What was the other?
Or regarding portfolio, do you aggregate on the level of material number or product group?
Okay, we go on the lowest level possible, so SKU. SKU, so means variant, shoe, size, you know, the lowest value, but we always use the context of higher value. So it's not just forecasting because you cannot, you know, even, I'm talking about shoes now because we had a client in this, you always have to put context to what the brand sells overall, you know, not just Nikes, but also Nike as a brand. So we do lower up all the lowest value, but we also use the context of the higher values.
Okay, thank you.
We have another question. Yes?
Thanks for your presentation. I have 2 questions. The first one is, you talked about it's an automated way and you can do across multiple industries. So my question is, if we have different formats of the data, so which is different, so how do you plan to, how are you automating across different use cases? And the second question is, sometimes you might also want to include external source of data. So is there some way that you're actually working with that? So for example, information about weather could be useful for forecasting demand of certain products. So do you also include external data also? This is the second question.
I mean, it's a product. It's a product. So base product definitely has its own template data that fits for the product. We always expand it because every client needs some customizations, external, not external, let's say internal, but data that we are not yet prepared for. That's why implementations go with customization. There is no one size fits all ever. It actually is. If your company is really bad at forecasting to the level that you're doing manually from the head, then even the basic solution can do a better job. But we always do customization. It's a product that allows lots of customizations for forecasting, whatever it is, and we connect to any external data that is needed. Because forecasting is built this way that you can add more data. If a client really, you can have a case where a client really says that some specialized external data really helps them with calculations. You can then upgrade forecast, so to say, with that external data.
And I think that we have one more question. Yes?
Hi, sorry, just a quick one. So how, in case of manufacturers and distributors, how do you deal with the difference between sell-in and sell-out? Because that's always the messy and tricky part, especially in this region.
I didn't hear.
Sorry, one more time. So how do you deal, in the case of manufacturers and wholesalers, how do you deal when you do forecast? Because at the end of the day, you want to have a forecast which would match the actual sales. But typically, these guys do not have access to sell-out data, the data that the retailers have. So how do you go? Do you do some approximations, or what's the
You're
trick?
talking about data we don't have. You mean usually the data? What do you mean don't have? I mean, I'm trying to figure out. You can always, if you don't have like the data, you can use some API. I'm talking about like say weather today.
No. I'm talking about sell out. So let's how many quantities are sold. So typically,
I mean, if you don't have data, you cannot model it. I mean, let's say from the beginning. But I mean, we even have cases where the client doesn't have some data and they put it some Excels, and I know it's not perfect, but even better than nothing. We have those cases. I mean, when I'm saying not data available in ERP, if they don't have it in ERP, we had cases when they put some Excels for some not that big data. So we have even those cases if they need some context. If you mean about modeling,
no,
what
I'm referring
is
to this case because if you think about, I'm a producer. Let's give a context. So I sold.
If you, sorry if I stop you. I have one more case you're probably thinking about when you don't have sales like stock out or something.
No. I'm saying this. So I'm a producer. So what I have in my ERP that I sold 100 pieces to this retailer. Okay, and today and tomorrow I'm going to sell 50, and I'm going to sell next day 150. But I don't know how much he sold to the end customers. Typically, I don't have. That's the sell-out data. The data, how much the retailer have sold to the final customers. And this is important for me because my actual sales, that's why I'm asking, or maybe it's not. So maybe you just base your forecast on selling data, how much me as a producer is selling to the retailer. So that was just a question because typically for the producers, they do not have much access to the sell-out data, the data that retailer sells to the end customers.
How much? I mean, it depends. If I get the right thing, you're thinking how much, what time? I'm not here.
No worries. That's fine.
We can talk later if you want.
Yeah, sure.
You know, sorry for that part.
Okay, thank you very much. It's time for our coffee break. And see you here in 15 minutes, I think. That much is left.